So let's take a look at this example. We have this, we're going to start with something very straightforward. We have a rectangle, and we want to find what is the, so this is X, this is Y. We want to find what is the area moment of inertia for this rectangle about X and Y axis if rectangle is put here. Should I, okay, maybe I should use this color. This is a rectangle. This distance is B, and this side is H, width of B, height of H. All right. We can write find the moment of inertia about both X and Y axis. All we know is Ix is integral y squared dA, and Iy is integral x squared dA. Well, that we know. And remember, we said previously, I told you that when we have this dA, that means this is a double integral. Right? So we have to convert this double integral into a simple integral. How do we do it? By taking an element on the area we're calculating this double integral on, and make dA into simple integral, or use dA to convert this into simple integral. For Ix, I'm taking integral, I'm calculating integral along Y. So here is the element that I have to consider. This element has the area of dA, which becomes B times dy. Right? B is width, dy is, well, change in y direction. This is y. Right? Y away from. It's a very thin element, has some area, and this is y. So the first one, I just plug in. I say integral y squared. I plug in dA as b dy. How y changes? Y changes from 0 to h. Right? I went from double integral to a simple integral that I can put the limits and just calculate them. Right? This becomes b comes out, becomes b times 1 over 3 h, 1 over 3 y to 3, changing from 0 to h, it becomes 1 over 3 bh cubed. To calculate Iy, I have x inside my double integral, by x squared. So I want to write things based on x. So I'm going to change, I want to convert that dA into something that has dx in it, so I can actually take this integral. So I'm going to now take a different element. Right? Consider a different element. You can draw it here. And say this is x, this is y. I'm going to redraw that rectangle. Now I'll take this as an element because I'm moving it in along x. I want to get dx. This is now dA is equal to, you get h, right? This side is h, this side is b, so the area is h times dx. h times dx, and this distance is x. So I replace dA, so integral x squared, dA is h dx. This becomes, h comes out 1 over 3 x cubed, changing from 0 to h. X changes from 0 to b, sorry, not h. Like that's the limit for b, for x. X goes from 0 to b. So this becomes 1 over 3 h b cubed. So these are the values for area, moment of inertia, or briefly moment of inertia, is about x-axis and y-axis for a simple rectangle if the coordinate system is placed on the corner of this rectangle. All right. Now, you can do these calculations very, how shall I put it, in depth with triangles, circles, semicircles, and in your textbook there are multiple examples how to calculate this integral for those. Now, my experience is most of you are not very familiar with taking an element and converting double integral into a single integral, at least from what I've seen previously. If it's a different case for this generation, let me know. So we will be less focused on this, but I just wanted to show you how this works. All right. Another example, maybe I can refer you to the textbook. Take a look at sample problem. Also, take a look at sample problem 9.2. You'll see that actually there is also some for a different area that this process has been done.